probability. Definition here is really kind of a simple definition. It's probability that involves geometry. I guess I'll be a little more specific. Probability that involves geometric concepts I'm just going to abbreviate that. Such as length and area. Oops. Such as length and area. Okay? So again, this is our big tie-in to geometry here. Tone down the brightness a little bit. Dial that back some. Okay. So one thing I want to point out about probability, and this is one thing that you would have caught in that second lesson that we're skipping over today. To find probability, the general formula for any type of probability is the desired outcomes divided by the total possible outcomes. And I'll show you what I mean by that with this first problem. Okay? So probability is always what you want out of what all the possibilities are, like a fraction. Okay? So really we're just going to do a few examples here, and then I'm going to turn you loose on some homework. Okay? Point X is chosen at random somewhere on this segment. Find the probability that X is on segment BC. Well, how long is the part that we want it to be on? 7. We want it to be on BC, right? So for our probability, we would say it's 7 out of, now we know it's going to be somewhere on this segment, so what is the total length of the segment? 14, yeah. So it's 7 out of the whole thing, which is 14. Okay? And then, yeah, I would either simplify it as a fraction, so I would take your answer as 1/2, or if you wanted to turn that into a decimal, you could, which would be 0.5. I would take your answer either way. Or some people like to turn these into percentages. That would be like 50%. I'd take that too. Okay, so you can leave your answer as a fraction, a decimal, or you could make it, you could move the decimal twice to the left and make it a percentage. I'm sorry, twice to the right to make a percentage, and it'd be 50%. I'd take your answer any one of those ways. Not hard, right? Okay. Chicago Transit Authority train arrives or departs the station every 15 minutes. Assume you arrive to the red line at a random time. What is the probability you'll have to wait 5 minutes or more for a train? Okay, so we've got 15 minutes between when one leaves and another one starts, right? So I'm going to kind of diagram out. Here's 15 minutes, right? So this would be like 0, this would be 15. Okay, so this represents a 15-minute block of time. Okay? Where would I have to wait 5 minutes or more? So like, this is when the train is going to arrive, right? So 5 minutes back from that would be what? 10. So if I arrive anywhere in here, I'm going to be waiting more than 5 minutes. Do you agree? So that's how many minutes out of 15? 10 minutes. So the probability that I'll have to wait more than 5 minutes is 10 out of 15, which would reduce to 2/3, which is also 0.6 repeating. Okay? That makes sense? How to set that one up? You look at 15 minutes and then you say, where am I waiting 5 minutes or more? That'd be the first 10 minutes of that 15-minute block. Okay. This one, there's just some terminology in that sounds a little confusing, but this is one of the biggest types of problems you're going to see with geometric probability is target questions. A skydiver must land on a target of 3 concentric circles. The diameter of the center circle is 2 yards. The circles are spaced 1 yard apart. What is the probability he'll land in the center? All right, we need to figure out how to draw this picture. Does anyone know what concentric means? Okay, they're circles inside of each other. This literally means they share the same center. Okay, but like they're inside each other, like Marty said. So what I have here is I have like a center circle, and then I have another circle around it, and another circle around it. Basically, it's a target. Okay? The diameter of the center circle, which is here, is 2 yards. And the circles are spaced 1 yard apart. So that means that this distance here is 1 yard, and this distance here is 1 yard. Okay? And then I could go 1 yard over here on the other side also. And I want to know, if I know for sure the skydiver lands somewhere on this big circle, he lands somewhere in here, what's the probability he's going to land in the center? Okay? So remember, it's always what we want over the whole thing. So I'm going to do the area of the center divided by the area of the whole target. Does that make sense? Okay, how would I get the area of this center circle? I heard pi.
Pi times 2.
Almost.
Pi times 2.
Okay. Okay, it's pi times radius squared. So if the diameter is 2, what's the radius? The radius is 1. So I'm going to go pi times 1 squared. For now, I'm just going to leave it like that. And you're going to see why in a second. Okay? Over, now I need the radius of the whole big circle. Okay? It would be 3. Yeah, a couple ways you could think about it. Either I could add up the whole thing and that would be the diameter, and then I could cut it in half, right? So the whole thing would be 1, 2, 3, 4, 5, 6, so half of that would be 3. Or I could say, well, I'm going to start at the halfway point of this circle because that's the center. So this would be 1, 1, and 1, which makes 3. Okay? So the area of the whole circle is going to be pi times 3 squared. What's going to happen here? Anyone see anything nice that's going to happen? Matt?
Are the pies and the squares?
The pies are going to cancel. The squares don't. The squares are kind of stuck to their own number. Okay?
It would just be, well, 1 squared is 1, and
Yep.
3 squared is 9, so it would be 1 over 9.
Exactly. Yeah. 1 squared is 1. 3 squared is 9, so your probability is just 1 out of 9. Okay? But the pies cancel out. That's why I left it in kind of that exact value form. I didn't type pi into my calculator or anything. I mean, you could, but you just wouldn't come up with such a clean fraction here. Okay, so I would just write it out like pi times whatever squared, pi times whatever squared. Your pies are going to cancel. Okay? Every time. Yep. As long as it's a circle. As long as they're both circles. Yeah. Everyone good on that one then? Okay. Try a couple more in the back here. Oh, I guess there's only one more. Yeah, not hard at all, is it? Okay. So we're going to use this spinner to find a probability. Now, look at these are measured in, like, they're giving you the central angles, which are degrees. These would all be degrees out of what? Out of 360. So when I say that I want the piece that I want out of the whole thing is 360. So probability of landing on yellow, this one would be yellow, the Y. So that would be 45 out of 360, which I think reduces to 1/8. Which if you wanted it as a decimal, I think is 0.125. Okay, landing on purple, I'm going to assume purple is P, so that'd be 105 out of 360. Well, I might need your help simplifying that. Anyone have what that reduces to? Okay, if you get a decimal, just hit the math button, and then hit enter on fraction, and then enter one more time. 7 out of 24. Or you could, and it would have been fine also to just give whatever that decimal was. I don't remember, I don't know what it would be, but when you divided that and you got that decimal, you could have just left your answer like that too if you didn't want to do it as a fraction. Okay. Probability of landing on neither red nor blue. So I don't want to land on red, and I don't want to land on blue. So what am I going to do?
Add up the other one.
Good. Let's add up the others. So this is going to be 150 and 90. So this whole thing is 240. Did I do that math right?
Yes.
Okay, thank you. So 240 out of 360, I think is going to reduce to 2/3, which is 0.6 repeating as a decimal. Good? Easy? Good. Glad to hear it.